be looking with the logic design, how the logic design and basic building block of 8085. So how the instruction set is working and how to depict the values. So if you remember, yesterday we have stopped here. We have seen that binary address space could be converted into hexadecimal space. Next, if you get any such values, you have to be sure enough that you are able to calculate. Like if you see 256, M means megabytes. How can I say it is bits or bytes? If it is 8, it is written, you can always assume it is bit. So it is 8, so it is 256 megabits. 256 can be written as 2 raised to the power 8, and mega means 2 raised to the power 20. So it becomes 2 raised to the power 28 cells of memory, which is similar to 28-bit address space. So that is how you can calculate the size of memory, whether it is in terms of address. Here you get the cells we were looking at. So if you are able to know the last memory address, then you can of course know how many number of cells are there. If you know the number of cells, you may know its space, right? So that's what we are doing with it. We are calculating the basic space. In operating system also, when you'll be studying this virtual memory, physical memory, then you have to calculate virtual memory, physical memory space. So with similar thing you'll be finding. If you've got 32G, that means gigabytes. So if you have gigabytes, uh, 32 means 2 raised to the power 5, giga means 30, so you've got 35 cells. That means there is 35-bit address space. Now, memory could be byte addressable or word addressable. Byte means when it has got 8-bit, then it becomes 1 byte, means it is byte addressable. When it is word addressable, when we are not defining how many bits we are providing. So when we say it is one word, it could contain 8, it could contain 16, it could contain 32. That means word is not defined as a memory. As we know, 8-bit is equal to 1 byte. So if we are defining in terms of bits, then we can say it is byte addressable. Otherwise, it is word addressable. Generally, the processor are calculated in word addressable because we never know that how many bits of space, address space it is having. So let's say if it is 32, they say it is one word. It could be 32, it could be 64, or the representation is not given. So that means word length could be anything in word addressable. That means 8, 64, it could be anything. Whereas in byte, it will be defined that there will be 8-bit cell. What is the advantage of having word? That means you can, vary the cell size. So that is why word addressable memory we are having. So there is no ambiguity in byte addressable. You know that if it is 8-bit, you have got 8-bit, right? If you have got 16-bit, you have got 2 multiplied by 8-bit. So there is no ambiguity. Whereas here, you just have the cell size could be anything. Whereas in byte addressable, cell size is fixed, 8-bit. Whereas here, whatever the length of the cell is, it becomes that one word, right? If it is 32 GB, let's say RAM, so the one cell size could be 1 GB, or it could be less than that depending upon how we bifurcate in memory space. That's all. So here you can do certain things like understanding all this. Next, yes, this is what I was telling yesterday. So when you have one such command, let's say move AX, your AX is the register name. So this is the microprocessor or processor register which has got fixed name. So registers are always called with names, like you have AX, BX, and these are containing 16-bit address space. Whereas memory is always referred with the address space. And move means you know that whatever is here, it will be moved to memory. So in microprocessor or in assembly language or in machine level language conversion, you always assign this from right hand side to left hand side. Like for example, there is simple thing like A equals B. So always B value is assigned to A. So that is how we write when we have 2000. So whatever is at this address space, it will be moved to AX register. So this is the mnemonic code. It is also known as op code, which means you can perform any operation. What operation we are performing now? We are moving. What we are moving? From this address space, whatever is containing in this address space, that data is moved to AX register. This is a type of operation with 3 opcode. 3 opcode means 3 sequences of data is required. One is instruction and 2 are the data values. Can we do it with 2? Yes. You have got many operations like you go with A++ or B++. Likewise, you can just find out the memory address space, and there are so many other operations which can be done using 2 opcode. So this is the destination register. AX is 16-bit as I told you. And this is the source memory. Memory is always referred with the address. So suppose if we say it is 2000, this is a byte address. So here in AX, when we say it is 16-bit, we have got from 0 to 15, which means 0, 1, 2, 3, 4, 5, 6, 7, and then we've got 8, 9, 10, 11, 12, 13, 14, 15, which makes it a 16-bit memory address space. So when we have 16-bit memory address space, you get this higher bind, you call this higher bind 8-bit, you call this lower bind 8-bit. Now, suppose if some data is there which you wish to store in AX, will you first start storing it from higher bind or lower bind? This is one question. Now, to understand this, that how the memory storage can be done, you just imagine that this is a memory storage. All right, it has contained this is the address space. So at 2000, at 2000, you have got this data 12h. 12h means you can write 12 in terms of binary language. It is hexadecimal. You convert it, you get something this. You convert it, you get something this. So it is a 16-bit address or 16-bit data containing at this address, which need to be moved at AX register. So in simple terms, I can say this 0 or this 1 need to be stored at here, this 1 at 1, this 0 at 2, this 0 at 3, this 0 at 4, this 0 at 5, and so on. So like this is the lower part, this is the higher part. You understand this? Now,
could you explain that again, ma'am?
yes. So what we have this memory address space. When we have this memory address space, it is some data is there. Which data is there? This one. Let's say this is the data at 2000 and 2001. The data is this. You can convert into binary from hexadecimal, convert into binary. So this is the higher data at 2000, sorry, at lower bind. This is at higher bind. That means you can convert from hexadecimal to decimal, you get this value. You convert from hexadecimal 3, you get this in binary. You can check that. How to check? You just write 2 raised to the power 0 multiply 0. 2 raised to the power 1 multiply 1. Likewise, you don't count it. 2 raised to the power 0, 1, 2, 3, 4. So 4. 2 raised to the power 4. What is 2 raised? No. 0, 1, 2, 3, 4. 2 raised to the power 4 is 16. It is supposed to be 1 is supposed to be here, right? So when you have 2 raised to the power 0, 1, 2, 3, yeah. So 1 is supposed to be here and 0 is this. So this is 0, this is 1. So the data is to write 12. Maybe you are getting confused here. 0, 1, and then you write 0, 0. So 2 raised to the power 3 means 8, and 2 raised to the power 2 means 4. 8 plus 4 means 12. So maybe this binary digit is written wrongly. If you check 3, 2 raised to the power 0, multiply 1, and so you get 1. Then 2 raised to the power 2, multiply 1, so you get uh, 2. 2 plus 1 is 3. So you know these conversions?
Yes, ma'am.
Okay, then it's great. So you can do the conversions. So once the conversions we have done, now what we are supposed to do, this data need to be stored in AX register. Why we are storing? Because we are saying that this data, which was the binary conversion of 12H and 3H, this data need to be stored in AX. And how is the look of AX? It is 0, 1, 2, 3, like that up to 7. And from 8 to 15. Why is it from 0 to 15? Because it is a 16-bit register. So every bit can contain one binary digit. Let's say at 0 cell you can store something, at 1 cell you can store, at 2 you can store, at 3 you can store. Simply you can assume that it is array. Here you got some memory space and you can store here because it is nothing but AX is your register. So when you have to store this data, what you can do is, one option is take it and put it at higher bind, or you take it and put it at lower bind. Vice versa can be done for. Take this higher bind value at 2001, that is the next value of this memory cell. You can store it here or you can store it here. So that means it is creating ambiguity for the microprocessor that which value to store, like we should start storing from lower bind or higher bind. So that is a concept known as indaneness. Indaneness mechanism has got two types. One is little indane, one is big indane. What you do with little indane? You take lower address contain lower bind. That means which is the lower address? This is your lower address, because the address is starting from here. This is the higher address. So you take this lower address and store at lower bind. That means first value will be stored at lower side, which is starting from 0. And consecutively take higher address at higher bind. So this is higher address. You store it at higher bind. Likewise, there is so here you can see the representation. At 0 you are storing, from 1 you are storing some value. So lower address, lower bind. And big indane is just opposite to this. That means at lower address you are storing higher bind. So if it is the lower address, you are storing the value of this higher bind. So you start storing this value. So what generally, for universal conventions, the microprocessor which are embedded, they are using little endian mechanism. So if you get any question related in exam and we have not mentioned that which indianness it is, the technique is opted, then you always consider little endian mechanism. So that means lower address will be stored in lower bind. And you can always say this, that as the in the question it is not suggested that which indianness mechanism they are following, so we are considering little indian. If you wish, you can consider big indian as well, but whereas you have to explicitly suggest that you are going with which indian mechanism. Any doubt in it?
No, ma'am.
So next is, so by default, you'll be storing it. And as you can see, like you can see the example little later. Next we go with the pin structure. So for pin structure, we are going with 8085 micro controller. So microprocessor. Here we are doing this one, logic design, CPU building block, that what are the basic building block of 8085 microprocessor. Let's see how it is. So we are doing it. Yeah. There, before coming to the microprocessor, it is over somewhere over here. This is microprocessor, whereas it doesn't consist of all the pins. So still, the after telling every detail about microprocessor, I'll come to
Excuse
the,
me, ma'am.
yes, pin diagram. Yes, yes.
Ma'am, why are we considering 2001 if our base address is 2000?
What, please? Base address. We are considering base address as 2000. No, no, no. This is just an example I have taken. I have not considered 2000 as base address. No.
So, ma'am, we have written over there 2000 and we are writing 2001 and 2000 down.
Yes, yes. 2000 and 2001. Yes, I'll come to this. But okay. Yes, yes. Please tell.
Yes, ma'am. So, why are we taking 2001 there?
2001 here. See, because this memory space is 8-bit. So that means it can only contain 8-bit of data. That means the other data will go to the next address space. That means this 2001. So when you write a C program and you say that the variable you declare int a equals to 10. So when you say int a equals to 10, so that means in 2000, when we used to have, let's say, 16-bit microprocessor, then a equals to 10 can be stored at one cell. So that means one word. But if it is 8-bit, that means 10 has to be stored in two memory spaces. If it is, we say that the nowadays the int a equal to 10 contains 4. So then it will be storing in 4 consecutive memory address space. So that is why
Okay, ma'am. Got it.
yes, yes, depending upon the size it is stored. Yes.
Hmm.
Yeah. So now we come to the pin structure, just defining basic this terminology. You can also read these. So processor consists of active low pin, active high pin. Low pin means whenever there is, this dash operation, when you read and there is a dash operation, that means it is active low. So active low is always enabled at 0. So that means if we have to perform read operation, it has to be active low. So that means if we are passing 0, or then we are getting read operation. If the pin is active high, so there are some active high pins like ALE or INTR. So when this pin is only enabled when the input is given as 1. So if you get certain pin like dash sign over those symbols, then these are active low pins. Active low generally means if I give 0 input, this will be active. And when I give 1 as output, it will be active. That is why active sign is given. Low means when you give 0, it will be active. When you give 1, high means 1. So in binary language, you have only two things, low and high, 0 and 1. So when will it be high? When you give 1. Next, there is time multiplexed pin. That means these pins will be enabled when you have certain timings provided. Like for example, in 8085, there are some less address pins and these address data lines. So we have got A D0 to A D7. A means address pins, D means data line, and whereas we have A to A15. This is in 8086. So what does that mean? This same pin is acting as address pin at one time and data pin at second time. And 8085 is a 8-bit microprocessor, so you will only find pins from 0 to 7 which are required because these are generally address lines. So if it is 8-bit, you require 8. If it is 16-bit, you require 16. That is how we can, relocate the address to with those many number of bits. And then we can easily find the address space that we have seen in the formula. So when we have this 8-bit, when to use the address bus, suppose if memory, there is a microprocessor, it is generating the request that get this data from the memory. So the address bus will be enabled. Yes.
मैम जो पिंस आप बोल रहे हो ये मतलब सीपीयू के फिजिकल पिंस की बात कर रहे हो?
Yes, CPU के physical pins की. I'll show you one something. So how actually these are basically in microprocessor, you can find the IC pins. So, okay.
Ma'am, when will you be uploading these notes?
These notes I will upload. I just need to scan few more pages. So I'm making it one. Otherwise, you might get confused if I keep uploading some and some. So give me 2 to 3 more days time, and then I will upload. Like it is taking me time to scan all of them, and there are few incomplete parts. So I'll be writing this weekend, and I'll shortly upload. Yeah. So 1 second. I come back to 8086, but usually we use this in IoT, so it is easy to understand. Yes. So this is the IC and this is the processor that we are talking about. Hardware part will not go, that it consists of some transistor, resistors and ICs, and that's how it performs the operation. So which pins we are talking about are these pins, this one, this one, this one. So likewise we have pin, and how to connect it to the peripheral, like here you can connect your address bus, and of course using in Arduino we use some pins which are connector pins, and in microprocessor there will be some SATA cables, serial cables through which we like if you have desktop monitor, you see that there is address bus, so there will be some from the hard disk, there will be SATA cable which will be from hard disk connected to the CPU, so that is how the this thing is happening. Now I Arduino. So which when we are talking, yes, so IC looks like this, right? Now we come to 8085.
Ma'am,
Yes.
ma'am, what is this ICS?
IC means integrated circuit. So the circuit is made in terms of that they have this coded, hard coded it. So you use this kernel and you have BIOS, and these ICs are programmed, and they have certain, like if any microprocessor, there is a programming code for microprocessor itself. So if you are coding in C, you compile your program. So compiler itself is made in some language. Likewise, when you are running microprocessor, which pin to, like these are all the pins of 8085. So these pins will be hard coded that they have to perform certain action. Whenever this pin 1 is sent, it has to perform certain action. So who is having that programming? This integrated circuit, which is having the little program and plus the logic designs, that how it is getting connected to other peripherals and every part of it. So yes, understood?
Yes, ma'am.
Okay. So this is your pin diagram that you will be studying at last in your 8085. These are your address pins. Address pins are also sharing data lines. Now you might say that why data lines are shared by address bus or address pins. I'll tell you. When you are carrying the address, that is also a data, yes. But when you are saying that microprocessor has generated a request and there is some address to be fetched at, data to be fetched at some address, at that time you are not carrying the data. So only address pin is getting used. And in order to, this IC, I showed you how the IC look like. So this is that same IC. Now, if we do not share these lines, then there will be a problem because we have to create a bigger IC if they are not sharing. And then you can say, okay, so why these higher pins A6 to A15, why these are not sharing the with data? Because see, 8085 is only 8-bit data it can store. It is working on 8. So that means we should have data address bus should be of 8. So that is why we have from D0 to D7. And from A0 to A7 it is getting shared. From A8 there is no sharing. So that is how you can look. I'll also share one more PDF apart from my notes of 8085 microprocessor to make your concepts more clear. Yes. So this is AD0. So it could be enabled as address or it could be enabled as data. So the power who has power to enable these pins is known as time multiplexed pin. That means there should be one more additional pin which is enabling whether it is to carry data or to carry address, and that pin is ALE. So whether it is carrying the address or it is carrying the data, it tells. So if the pin is 0, it means it is carrying the data. If the pin is 1, it is carrying the address. Yes. Any doubt in this? Okay. So then there are two types of memories. One is buffer, one more is latch. Buffer is temporary storage where there is no locking. So that means whatever data comes, either it could be input signal or output signal. So you can ask me which kind of data. So in modern times, you can suggest that when you are inserting a pen drive, there is IO operation which is happening. So lot of data will come. Yes, that is data, but it is address. Sorry, it is actually data. But here we are talking about even there when you attach two microcontroller or two peripheral, then they do certain things like handshaking operations or some other, the drivers need to be installed, or there are so many operations which need to be done when, suppose if you are inserting a pen drive or mouse, a mouse through USB, so it try to detect through USB, it assigns a port number So COM 1, 2, 3, 4. Then it see whether the compatible drivers are there or not. Then it checks whether this particular this device is compatible with the current software or not, any update needs to be required, all those things need to be checked. That kind of data we are talking about. So whatever input comes, it could be stored here in the buffer and it is temporary storage without locking. Whereas latch, it provides a locking system. That means it will tell that when data to come and when data to block. So to enable the data, we use this STB pin, and active low means we are not enabling it. So it is for storage. Let's say we want to store something, store the data. So for that you can make the enable or disable pin. Likewise, if you go for input output enable or disable, that means any input device is connected and you wish to lock it, that means no device should be connected, or right now there is lot of other tasks which are going on, you are not enabling it, so OE pin is there which can enable or disable. Now here it is active low pin, this is active high pin, so you can always check that which is active low pin, which is active high. You can ask me that how these pins are used. Like in Arduino, I have showed that there are various pins. Likewise, in 8085, you can see various pins. You can also check the, I'll give you an assignment, if you have i7, i5 or i9 processor, what are all pins, how it is enabling, what is happening, all this you'll be studying. So whenever you see this new pin, STB let's say, you go to the net, check what it is doing, and that is how you come to know that, okay, this is the operation of the pin. I have not covered all, I'm just telling you about few. How to log the data, you can see that, how data is getting logged. Next is micro interfacing, how the interfacing is done between the CPU and memory. So let's say if we have, so what is the time? It is 5:10. We have class from 2:30, 15:10. Class from, okay, we have time, 10 minutes left. So when we have this CPU, it is the microprocessor mainly. It has got all the operations like read, write, and there is all the operations of 8085. You have seen the pin diagram. Next, there is memory. Memory has got address. What are all operations in memory you can do? You can either read the memory or write the memory in the memory, like read from the memory or write to the memory. And there will be address space which you can always connect. Like for example, in 8085, the memory is the address pins are 8, A0 to A16, A15, that means 16 bit, and depending upon the current, if you see the i9, you have lot and lot of memory that needs to be addressed. You can check those. Yes, now how to generate the memory request, this is one thing. Suppose this memory request is generating, let's say this is the memory request 2080H, which is in hexadecimal, and we got to read it. So one thing that you have to understand is we have to see the machine cycle or memory cycle. If ALE is enabled, that means only address lines will be carried. If ALE is disabled, that means data lines will be carried. So this is the clock cycle. It means that after every 1 second, or if it is microprocessor, after every microsecond, this operation is happening. Generally, what is CPU cycle? It is depending upon that what kind of architecture it is. Suppose if it is taking in micro, nano, or what, the cycle time could be any, but at one cycle it performs certain operation. It it has to fetch, then it has to decode, and it has to execute. All these cycles could be represented by machine cycle, or you can say memory cycle, or you can also say it as pipelining. In pipelining, we'll be studying that how these memory operations are happening. If you study pipeline and data hazard and memory hierarchy, that means cache memory, then you can cover the 80 to 90% of GATE syllabus, so it is that important. Next, it is ALE. In ALE, so these are my BTech notes. I was studying this subject in my third year, so I have written this state. Yeah. So if you see this ALE, it has got, let's say 1, how this is happening. We have got the hexadecimal has to be converted. So let's say the lower bit is taking the 08, the higher end is taking 02. ALE, when ALE is 0, it means we can read the operation. Read means address bus will be enabled. It will fetch this memory. So it will take this address and it will try to fetch the data at this. So once it passes or it reach to the memory space at this memory space, ALE will be enabled or maybe you can say disabled, and RD operation, that means is 0, and then we can write onto the memory. So that is how read and write operations will be enabled or disabled by the machine cycle. Next is bus structure. Yes, so bus structure is, this is the data bus that need to be carried. I'll just show you a block diagram of 5. So can we have this one? Yes. So 8085, this is the block diagram. If you see in the block diagram, you have processor, memory, input output, this is IO. That means from peripheral devices we are taking the input output. We have 3 things. One is address bus, which is getting the address, carrying the address. This is data bus, carrying the data. And one is control bus, which is controlling whether to enable data pins or whether to enable address pins. So this is the architecture of 8085. Whenever we talk about bus, data bus, these are the buses: data bus, control bus, and address bus. Bus means which is carrying the data. It could be data in form of address or data, actual data with which we wish to maybe addition, subtraction, or any processing need to be done. And then control bus, which is controlling the either data or address. So this is bus structure we are talking about those bus we are looking. So it could be CPU, memory, or IO. What is the characteristic of bus? It will transmit the data. So there will be some shared transmission. Why shared? Because data and address bus are sharing some of the pins, that is why. There are 3 categories that we have seen in the diagram, block diagram: address lines, data lines, and control lines. So in address lines, the basic address is getting carried. So when we say the address lines are from A0 to A15, that means we have got total 16 cells. And you know this calculation now. 2 raised to the power 16 multiply 2 raised to the power 10. 10 means kilo. 6 means 64, 2 raised to the power 6. You can always remember 5 is 32, 6 is 64, 7 is 128, 254 and 512 and 1024. If you remember till 2 raised to the power 15, it's fine. If you can remember 2 raised to the power 10, then it's like good. Then you can remember 2 raised to the power 20 is giga, 30 is mega. Sorry, 20 is mega, 30 is giga. So you can remember that kilo, mega, giga. Then you can easily do these conversion. Whereas if you see 2 raised to the power 10, you get 1024. Whereas we write this in K. K means kilo, means 10, 1000. So there is a minor difference of 24, but it is manageable. Still we write kilo. So whenever kilo is written, you always take it as 2 raised to the power 10, means 10 means 1024, but it is still written in kilo. So when we have 16 cells, you can always predict it is 64 KB memory. And that is how we find the memory. So when you have this RAM of 32 GB, then you can always calculate the cells. You can always see that what are the address lines or data lines could be. So that is how the assignment will be provided to you. In 8086, we have 20 address lines. So it is having 1 MB of memory. Next is data line. Data line is carrying the data. So basically it is the word length. We are not telling byte. We are telling word. Word could be, yes, yes.
Ma'am, we have class in 5 minutes.
Oh, okay. Yes, thanks for stopping me. So we'll stop here and we'll study this data line from next class. You can leave. 1 second, let me take down the attendance. Download attendance. Yes, done. Okay, thank you class. You can leave.